Hello, ladies and gentlemen. How are we doing? It's 2 o'clock. I am third in line for. There we go. How are we doing, guys? Yeah, it's chemistry time. So I am third in line today to talk to you guys about what we're doing to help you year 12s out with what it is you have got to finish. So who have we got in the house? We have got Iman, Benyan, Hadia, Kate. Maryful World, how are we doing? Good to have you. Good to see you. Thank you for joining us. Ruhab, hello. How are we doing? I think you've been with us all day, haven't you? So what is going on? Well, there's no school, there's no college. So we are here to try and help you with that. Let me just move my camera. I'm cutting the top of my head off. So what we're here to do today and for the next few weeks is to help you guys in year 12 finish the course. All right, because the last thing you want to do in September is rock up to school or college and not have finished all of the year 12 chemistry, because chemistry, especially the year 2 content, is very much built on the knowledge you have from year 1. All right. And the last thing you want to do, guaranteed, teachers right across the country are going to have to revisit this stuff in September because, are they going to really trust that you've done this from start to finish? Probably not. I don't know. Yes, Ruhab. Yes, I know. So, yeah, let's keep the chat to a minimum then if you just hear recapping, mate. So we've got a few year 13s in here. All right, that's fair enough. That's fair enough. But really, this is for year 12. So if you know any year 12s, spread the word, because this is all free content for you guys that we're doing over the next few weeks. Okay. In fact, the next few weeks, I think the next couple of months, to be fair. So let me just show you, if you haven't already, ladies and gentlemen. I'm just going to share my screen and let you know what the Exambulance is all about. Okay, so hopefully you should be seeing our TT website. Okay, so usually we're really exam focused. Obviously, it's all about getting the grade in the exam, right? But we've had to have a change of thought really over the last couple of days, and just to see what we can do to help students, because there's no exams anymore, of course. So this is the Exambulance. It's the study at home Exambulance. It's kind of based on the Exambulance that we're going to be releasing anyway, but it's to help you guys study at home. So you can register for all 3 of these. Doesn't matter what exam board you're in or what year, the Exambulance is the same for everybody. So make sure you get the chemistry one. So what are we doing over the next few weeks? Well, the Exambulance is this, okay? It comes in 3 stages. I'm going to stop sharing. So for those of you that don't know already, this is the Exambulance in a nutshell. So 3 stages. First of all, AS, year 1, whatever you want to call it, year 12, we're going to finish that content. Regardless of your exam board, we're going to make sure that you finish that content, get up to scratch with what it is you need to know, okay? Tried to enroll in the Chem Exambulance, but it's not working. All right, I'll check that out. Okay, let me just click on that link myself. Yeah, it should be working. Oh, right. Okay, I'll tell you what then. Let me just try that one more time. And that's no good if we've got a broken link, is it? So opening incognito. Yeah, so what you should be seeing is, when you click on that link, is this page. Okay, anybody getting to this page? That's really weird. Okay, well, I'll double check the link. It seems to be working for some people, but not others. Okay, no worries. Well, I'll fix that as soon as humanly possible. As soon as I finish this year 12 live, I'll go and fix that. Okay, guys. So what's it all about? Well, first and foremost, like I said, we've got 3 stages. First one is finishing the content. Secondly, we're going to help you get up to scratch with your exam technique. Okay, and then we're going to do an exam at the end of it. Okay, who here would be up for doing an exam at the end of this? So like a mock exam. So we're going to coordinate everybody to do it at the same time. Yeah, Hadia's up for it. Brilliant, excellent. Because at the end of the day, I know it's like, oh, we don't have to do any exams, but then it's like, oh, how do I know where I'm at? How do I know what grade I'm working on before I go back for second year? So that's really, really important. Okay. So we're going to try and coordinate everybody to do that at the same time. And we'll talk about how we're going to mark it. So quite how we're going to do that, we're still figuring out, but don't worry, that's the plan. Okay. So once you've done that, then the third stage is going to be start on some year 2 content. Okay. We're going to do as much as we can to get you up to speed. And I'll let you know exactly what all the links are and all the really important year 1 stuff, and start teaching you some of the year 2. Okay. Yeah, so yeah, that's a very good point, Benyon. So what we need to do is just log out of your TT account or open it in an incognito window. So if I do this, let me show you. Where are we? Here. So you got the screen here. All you need to do, I'm in Chrome, so I right click, open link in incognito, okay, and it should pop up for you, okay, and that's what we got there. Okay, so it's a bit weird when you've already got a TT account, so apologies for that, but there it is. So let's have a look at our study schedule, shall we, for chemistry. Okay, brilliant. So our study schedule here for chemistry. So here's the 3 phases I was talking about: phase 1, phase 2, phase 3. So this is the plan. So for this week, we're going to be really focusing on some organic chemistry. We'll talk about exactly what that entails before the end of this action hour, okay? But essentially, I've broken it down into 4 main topics that we're going to be covering this week, just to make sure we're all on the same page and we all are up to speed on this. So atomic structure, so that includes obviously atomic structure, electron configuration, mass spec. We need to do mass spec and stuff like that, and the calculations that go with it. So that's tomorrow. Wednesday, we're going to look at periodic trends, and that includes lots of different things. So we're talking about all the different trends in the periodic table that you need to know. We're going to be talking about first ionization energies and second ionization energies, because at the end of the day, that's a trend in the periodic table. Thursday is redox. So we're going to be making sure we're absolutely spot on with redox, because you're going to use it loads in year 2. And then lastly, we're just going to talk about bonding, okay? Different types of bonding, different types of questions that come up, okay? So is anybody in this room right now, has anybody not done any of those things? So give me a yes if you have done all of those things. Give me a no if you haven't, and let me know which one you haven't done. Okay, so atomic structure, periodic trends, redox, bonding. So most people done all of those things. So ITechX, which one haven't you done? Which one haven't you covered? Okay, so haven't done redox, that's okay. We'll get you straight up. Haven't done organic analysis. We haven't got there, Benyon, but yeah, that's fair enough. Okay, and that's really quite tough. That can be quite tough. So the kinetics thing you haven't done, and equilibria. Right, okay, so that's next week. We're going to do physical, and then the week after, we're going to do organic chemistry, okay? We may have to rearrange one of these. We might have to have a double session one day, because one of those days is my 40th birthday. So I'm officially getting old in the middle of the coronavirus outbreak. How do you get the schedule? The schedule is in the Exambulance course. So if you go to our website, tailoredtutors.co.uk, and you'll see a big white box there with Exambulance in it. And then you just need to click on the chemistry one, and that's it. So halo ionization energy, halo alkane, and alcohols you haven't done. So, I mean, it's impossible for me to cover the whole spec in 3 weeks. And of course, impossible for me to get into all the slight variances between all the exam boards. But in terms of the major stuff that you need to know, generally speaking, 90% of it is exactly the same for all the exam boards for chemistry. So Raseb, you need to right click, open it incognito. Just if you're logged in, you need to log out already from your TT account and then do it from there. Okay. So this is our year 12 schedule. This April the 13th to 19th, basically I've left that open, because if there's anything in here that that we think that we need to do some more of, if you feel like we need to do some more practice questions and stuff, if you feel like there's anything we haven't covered, then throughout the next 3 weeks, we can talk about that and we can add that in as we go. Okay, so we'll decide on these to be announced in this April the 13th week, beginning April 13th. We'll decide on those nearer the time, probably, you know, towards the end of this week. And yes, we'll sort that out then. So what happens then? Stage 2, the tailored tutors study method. Okay, so essentially this is where we're looking at exam technique. So where it's blue, there's not going to be live lessons per se. Oh, before we get to that, I do apologize. What I should say here is for each of your exam boards, so for AQA, EdXL, and OCR, I'm going to be opening up the content guide for you guys. So after each session, I'm going to open up the content guide for each exam board and make a few lessons previewable for you guys. So you can head on into the content guide and just watch some TT videos just to make sure you got your content knowledge all sorted. Okay, so I won't be releasing the whole course, okay, because of course, you know, we reserve that for our subscribers. But for those of you that aren't subscribers, we want to be as helpful as possible. So I'm going to open up just a few previewable videos, the main ones, the things that I recommend you need to watch. So in your own time during this week, you can watch those videos as we go. So as time goes on, I'll be opening up more and more of the content guide with key videos that you need to know. Now, those of you that are subscribers, of course, don't worry, we're not giving the whole course away for nothing. Of course, there are massive benefits of being a TT subscriber. That's asking questions within the course, being able to access the exam guide, of course, as well, and coming to our live sessions that we have just for our TT subscribers. All right. So like I said, we'll be making this as useful as possible for people who aren't TT subscribers, but equally there are massive benefits for those of you that are. So here we're going to be doing papers, 2017 paper 1 and paper 2, 2018 paper 1 and paper 2, and then this, ladies and gentlemen, if we can call it that, is our mock. So the last 2 weeks in May, we're going to do paper 1 2019 and we're going to do paper 2 2019, but they're going to be our final mock assessments, because by doing the 2017s and 2018s, we are practicing past papers. Okay, when we get there, I'm going to talk to you about the TT method and what we do and how we do it and how that's going to massively improve your grade. Okay. Intelligence monthly cost or fixed. So it's a monthly cost. Okay, it's a monthly cost. So it's a subscription. Okay, so you can check that out on the website if you're interested. iTech. I've enrolled on biology. It's not letting you enroll in chemistry. You need to log out. So really importantly, to enroll on a new course, it's just a quirk of Teachable, the platform we use. You need to log out from your TT subscription if you're already logged in, and then do it from there. Okay, and you'll be absolutely fine. It'll work. Okay. Right, so what's going to go after that? Well, third stage, we're going to look at some really key year 2 content. Okay, so thermodynamics, which is an extension from all the enthalpy that you guys have done in year 1, the rate equation and KP. So this is where we extend the kinetics and rates that you've done in year 1 and the equilibria. Third week, we're going to look at some transition metals. So look at the general properties of those, complexes and colors. So 3 sessions on that, because there's a lot to learn in transition metal chemistry. And then year 2 organic overview, we're going to look at some benzene, okay, which is massively important. And then the carbonyls. So that's the aldehydes and ketones. All right, aldehydes and ketones. So that's our plan. How does that look to everybody? What do we think? Just waiting for your answers to come in, guys. Okay, so you have to do we have to make a new account? No, you shouldn't have to make a new account. My advice is right click. If you're in Chrome, right click on the button, open in incognito and just do it from there. And I think you should be okay. Okay. Well, I was thinking about starting with organic, but I just thought over the next couple of weeks, I'll get an idea as to exactly what part of organics you guys actually need to do. Okay. It worked for you without incognito. Yeah, I'm really sorry about why we've had like 48 hours to put this together, guys. So if there is an issue with the link, don't worry, I'm going to check it out. I'm going to fix it and do the best I can. Okay, but it should be okay if you did do it with incognito for now. Okay. Yeah, Benny, that's a very good idea. We haven't quite worked out the exact logistics of it just yet, but we're just going to try and coordinate everybody to do it at the same time. Okay, so we'll do like a study with me session for an hour and 3/4 or an hour and a half or whatever it is, and say, right, everyone that's in this room right now, no chat. We're going to sit down. We're going to do this exam. So we'll open it up just before. We'll get you all settled down, ready to go with your paper. So that's it. Okay. So we're learning, doing some study with me sessions and helping you understand what the TT method is and how to use it during those few weeks there. So it's 1 paper per week per subject, keeping you ticking over. And then in June, we're going to start looking at, so basically doing it in a live class, essentially. Yeah. Okay. And we're going to be on hand to help you with this section. We're not going to do lives every day, but we're going to be on hand, various times during the week to help you with that. Okay. So what else have we got in here? I just want to run through this real quick before we start talking about inorganic chemistry, because we've only got a certain amount of time. So in here, you'll find something called a progress tracker. Now, the progress tracker is there for when you get to the TT method. So you can record your grades, okay? So your paper and what year it is, and attempt 1, attempt 2, and so on and so forth. We'll talk more about that when we get to the TT method and start doing full papers, guys, okay? There's some information here about the TT study method and how it works. And what we've got here are some useful documents. Now, this is the same for everybody to a certain extent. Obviously, this is the AQA one that we're looking at right now. You do whatever specification you're doing, you do that paper, okay? So if you're AQA, you're doing those ones. OCR, you do those ones, and so on and so forth. If you're WJEC or Cambridge or something like that, and you're here and we don't necessarily do your specification, but there's no reason why you can't follow this along with us, okay? So year 1, we've got links to the specification, subject vocabulary, command words, transition guide, so on and so forth. But here, these are documents that I've made, okay? So this is the chemistry guide, the overall guide for AS chemistry, what's included and what you need to do. We've got the A-level chemistry guide as well, because I should imagine the majority of you are just in the first year of the full A-level, of course. And this is your year 1 chemistry cheat sheet. We've got the same for year 2s as well. So those are the year 2s. You can find the same thing in here as well. Okay, so I'll just show you this. In fact, I'll stop sharing and bring up this cheat sheet and then reshare. Sorry to go backwards and forwards here, guys. So this cheat sheet here, this is something that is in the content guide, and you can download it. So it's got all the major equations and things that you need to know, common rearrangements, how to actually rearrange them and stuff like that, equilibria, common ions and molecular ions, acids and bases, common oxidation states as well, solubility rules, really, really important, and then all the practicals that you need to do for your exam board as well. So the year 2 one is basically this, plus all the stuff that you need to know in year 2. So Hannah, we're going to talk about exactly what we're going to learn in just a second. But yes, really, we start tomorrow. Really, we start tomorrow. Okay. How do you think schools are going to perform predicted grades for our year, because we won't be doing exams? So are you talking year 1 or year 2, Fatima? So, yeah, so year 1, if you're doing AS exams, so if you were entered for an AS exam, then essentially they'll do the same for you as they're doing for the A-level students. If you're not scheduled to do AS exams, but rather you're going to do internal exams, mock exams in school, then, well, there's only one way they can assess you, really, isn't there? And that is to test you when you get back. This the only way they can do it is set you a test, set you an assessment, set you a mock when you get back, and they'll use that for your predicted grades, along with obviously all the work that you've done so far. Okay. So can we start with organic? I mean, is there anybody else here that desperately wants to start with organic, or are you happy just kind of working through in this order? If you put happy, I know you're happy with this order. If you put organic, then I know you want to start with organic. Don't mind from Megan. Okay, so we're going to have to go with majority rules. Don't worry, we are going to get to organic. And if we need to spend more time on organic, that is absolutely fine. Okay, I'm here to help as much as possible, and we are going to try and get everything done. And as I say, I'm going to be releasing actual videos from the content guide to help you guys along as well. So it's not just this 45-50-minute session that we're going to be doing. Okay, I'm going to be giving you links to the content guide so you can just go and check it out for yourself. So for those of you haven't seen the content guide, I'm just going to show you what it is, okay? Because, you know, you're going to be going in there. I'm going to be giving you links to the content guide. So hopefully you can see this okay. What we've got here is just basically the whole list of all the lectures we've got in the content guide. This is the this is the AQA one, okay? So you'll have all the AS content here as well. So let's say we're doing atomic structure this week. I'm going to click on here. Maybe I will, if you're AQA, I'll unlock this velocity calculations one. So those of you the AQA need to know how to do the velocity calculations and how to rearrange it and so on and so forth. And, you know, this video here is me going through all that sort of stuff, showing you how to rearrange it and showing you how to do it, okay? So as we go through, you will not need a subscription for the ones that we're making previewable. So in other words, I'm going to allow you to kind of look at the videos just to kind of make some notes and stuff on top of what we've been doing in the live sessions on YouTube. So you don't need a subscription, but of course you're not going to get access to the entire content guide, just the ones that I select for you, okay? So in here, you know, I'll probably give you maybe 3 or 4 videos to have a look at, so you can just make some notes and stuff like that. You'll have access to our cheat sheets as well, not cheat sheets, but template notes, which basically give you a skeleton you can print out and you can write your notes on as well, okay? As we go through, I might reference the exam guide as well. So this exam guide here basically shows you all the AS past papers. So all these AS past papers and A-level past papers in here, you've got links to everything you need in terms of the mark scheme, data booklet, the MID sheets, which we'll talk about at a later date. And then you can get the videos for all the different questions. They're all organized by topic as well. So atomic structure questions, for example, all the questions from all exam boards on the time of flight mass spectrometer, mass spec calcs, electron configurations and ionization energies and everything in between. So this is the most in-depth analysis of past papers that anybody's ever done, okay? So like I said, that's for subscribers, but I will be referencing these as I go along. But like I said, you do not need to be a subscriber to get access to the videos that I release to you as we do these lessons during the week, okay? So we've got our plan. All right, we've got our study schedule. We've got all our MID sheets. This is part of the TT method that you're going to be doing when we start doing some papers in about 2 or 3 weeks time, 3 weeks time. Okay. So where should we start? Well, let's start with some atomic structure. Okay. Or no, physical chemistry is basically what we're doing this week, isn't it? All right. So let me just move my window over so I can see what you guys are chatting about. Okay, so share iPad. Oop. So inorganic chemistry. Oop, that's a rubbish bubble. So what's included in organic chemistry? What do we need to try and cover this week? Well, like I said, tomorrow we're going to look at atomic structure. Now, in atomic structure, obviously we need electron configuration, which we're going to be talking about tomorrow. So the 1s2, 2s2, so on and so forth, the rules that go with that and so on and so forth. We're going to look at the mass spectrometer. Okay, in depth as well. So we're going to be looking at a little bit about how it works. Not everybody needs to know how it works. AQA, you do, but it doesn't harm for you guys to understand, the rest of you understand how it works as well. And in terms of atomic structure, we may touch on ionization energies and ions and stuff like that as well. But really, I'm going to reserve that for periodic trends. Okay, which is the other one. Okay. I mean, yes, and I mean, physical chemistry for me, Hadia, that's more rates and enthalpy and equilibria and stuff like that. Okay. I mean, it's hard to kind of, we had 3 weeks and I wanted to try and lump everything together in 3 sections. That's all it is. So periodic trends, yes, we need to talk about group 2 and we need to talk about group 7 in particular. We may be looking at trends across period 3. Okay, I know that's an AQA thing, but it all actually is important for everybody, apart from their specific reactions. We're definitely going to be looking at ionization energies because that's a trend. Loads of other trends in here. Electronegativity. Negativity. What else is there? Atomic and ionic radius, or radii, we should say. Okay. What else is there in periodic trends? I mean, reactivity. I don't like that term because it's more about redox. Okay. Now we're doing A level. Yeah, reactions of the halides. So we're talking a little bit about redox there, maybe, but we don't want to spoil it because, of course, what we need to look at next is redox. Okay, so we'll be looking at identifying redox numbers or oxidation states, if you like. We'll be looking at specifically group 7 redox because that's massive. Okay, they love using group 7 to ask you redox questions. Okay, and then we'll talk about trends in redox, okay, and reactions in redox as well in general, and we're going to cover as much of that as humanly possible. Oh yeah, we could look at melting points and boiling points in periodic trends. That's going to be pretty jam-packed, 45 minutes, that, isn't it? But that very much leads into the last section we're going to be looking at, and that's bonding. So of course, we're going to be recapping metallic bonding, we're going to be recapping ionic, we're going to be recapping covalent, and we're going to be recapping IMFs. Now, it's all about the physical properties when it comes to bonding. You need to be able to compare and contrast different substances. You need to be able to describe and use the key terms to describe those different types of bonding. Spotting intermolecular forces, shapes of molecules, in fact, we need to look at too. All right, so we're basically trying to do the entire spec in 3 weeks here, but we're just touching on stuff. And like I said, the most important stuff is going to be kind of made previewable within the course for you guys. Okay. So as it stands, this is Tuesday, this is Wednesday, this is Thursday, and this is Friday. Okay, so those are the days that we're doing on it. Practicals is a great shout. So what I'll probably do is talk to you generally speaking about practicals. In fact, I will make a note and we will do just a practical session on practical questions. Okay, which is a great shout. I'm loving the idea of that. Okay. Yeah, I'm going to be doing this all over the week. So don't worry, I'm going to be live at 2 o'clock for you year 12 students every single day. I'm going to be live at 3 o'clock for year 2 students. All right. Now, year 2 students, if you fancy coming along as well to the year 12s, that's absolutely fine. But this is really just to make sure that year 12s have finished their content for the year. Okay. So the other thing, and somebody was just, I think it was Fatima that was asking about, let me just stop sharing a sec. It was Fatima that was asking about how your teachers are going to give you a grade or predicting how they're going to come up with your predicted grades for UCAS and stuff like that. I'm sure there will be guidance given to teachers, just like there's guidance right now on how to decide on the results for the year 2s, okay, the year 13s. One thing we're looking to do actually would be really nice if we can manage it somehow. If you come along, if you follow us on this journey and you do all those papers and, you know, you revise in readiness to do your 2019 mock, at the end of it, and you know, no cheating, then what we can do is probably come up with some sort of, I don't know, certificate, for want of a better word, for you guys. So you know, so we can say that, I don't know, Fatima spent 8 weeks with us here on Tailored Tutors, or 10 weeks or whatever it is, finishing the content, practicing exam technique, and then did the 2019 exam at the end of it and got a grade. Okay, so, you know, what we want to try and do is, it won't be official in any way. We're not going to be marking your papers. This is largely, wholly based on trust, really, to be honest with you. But you know what? We want to work with students who want to work. We want to work with students who want to do well. That's what we're all about here at TT, okay? We're not about the top end students who you know, are looking to go to Oxbridge or vets or medicine or whatever. Okay, and that's not who we're about. Yes, a lot of our students do those sorts of things, and it's wonderful because they get the grades. All right, but we work with everybody. You want to get from an E grade and you want your target to C, we can help you. Okay. You're working on an A grade and you're looking to get an A star, we can help you. So the one thing all TT students have got in common is that they want to do well. Okay. They want to improve. They want to work hard. So we will work as hard for you as you will for yourselves. And that's an absolute promise. All right. We always do. We always have done live sessions on YouTube and live sessions for our subscribers, which we'll continue to do as well. But right now, considering the current climate, we just want to help out. Okay. We know that thousands and thousands of year 12 students are just left out there kind of not really knowing what to do or where to start. Teachers are doing what they can, but we're geared up for this. We're geared up to do online teaching. That is what we do. So we thought, we'll step into the breach and we'll help you guys out as much as possible. So Aisha, you want to work? Brilliant. Okay. So peace of mind for teachers, Fatima. That's a very, very good point. Okay. When will the certificate idea be expanded on? When we've thought about it a little bit more, mate. We're just throwing ideas out here right now. And I think it's just something that we'd like to do just to show that you guys have been putting all this work in. Okay. So thank you, Inia. Then, we're full of good ideas, I'd like to think. So let's have a think. What can we do? I've run through all this stuff like really, really quickly. Okay. I'll tell you what, first of all, has anybody got any questions about the Exambulance or about the TT course, just in general? And I tell you what, we may as well get started on some atomic structure if nobody's got any questions. So if you've got a question about the course in general, the Exambulance, now's the time to do it. And if you haven't, just put nope in the chat and we'll crack on. Megan, is the Monday check-in still on? No, purely because we're doing, we're doing 7 hours of live YouTube today. Ronnie's going to be doing a study with me session later as well. So that Ronnie doing the extra hour. So we won't be doing that today. What order are we doing the TT method? Well, that's detailed in the schedule. Okay. Do we need any resources printing? Not for this week. If you go into the course and look at that previewable content that I'll give you a link to from the Exambulance, then there are things that you can download there, like the template notes and things like that for those particular sessions. But no, you won't need anything when you come to the live sessions. Okay, we'll provide everything you need. Is that we've got more time to go back doing AS papers or no? You can do, okay. If you're year 13, there's no reason why you can't do some AS papers. Jury, I mean, year 11, do you think I should prepare a bit throughout the summer for chemistry? Ooh, so you're year 11, right? Yes, we are thinking of ways we can help you guys as well. We have a transition kit, which is basically a course that you can sign up to that actually prepares you, takes all the GCSE content you need to know, and tells you what parts of it you will need for AS chemistry and AS biology and AS maths. Okay, so it's a transition kit. Keep your eye out. If you want to join these sessions, then please do go ahead. But we're going to be releasing a transition kit for our year 11s very, very soon. Okay. OCRB, will it still work for you? We don't do OCRB specifically, but I do know of students in the OCR course, it's OCRA, that use it. I think about 80%, 85% of it is very, very useful for you. The specifications in a slightly different context, but it will still be relevant to you. A vast majority of it will be relevant to you and you will find it useful, okay? It's not specific to your exam board. The exam papers aren't in there or anything like that for the exam guide, but certainly the content guide is worth doing, and maybe even the exam guide as well, just to practice certain styles of questions and things. How many hours a day is ideal to work as a year 13? Well, I mean, that's completely up to you. I mean, what we're doing is we're just doing 1 hour a day per subject live on YouTube for you guys. Anything you want to do on top of that is completely up to you. I would say, you've got to keep yourself occupied. You've got to keep your toe in the water. Just do a couple of hours per subject per day. I know it's 6 hours, but you know what? If you're using action hours, it'll go like that. Okay. Where's the Exambulance song? Oh, well, you know what? I mean, this has kind of got out of hand a little bit. I was kind of joking about the Exambulance song, but yeah, I think I think I've got a little ditty. I've kind of pinched another song and kind of crowbarred it in there. I'm anxious about the practical paper because I haven't been able to complete all the practicals. Don't worry about the practical paper. I mean, there is no practical paper. The practicals are kind of, you know, spread out through all three papers. Really, I think edXL, the one more than most, is one that does tend to focus on practicals more in the paper 3. But if you haven't finished the practicals, we'll do what we can to kind of make sure you get your head around them. Okay, and they're all detailed within the course as well. There's a video for every practical that you need to do. So yeah, so I don't know, the Exambulance song. I kind of want to do it for Rich and Ronnie first. They haven't heard it yet, but you know, we'll that'll come. All right. So is that all the questions, guys? Hopefully, I've answered all those for you. So 10 minutes. So let's talk about atomic structure, shall we? So let's get ahead of what we're doing tomorrow, and we'll have a little recap tomorrow as well. Okay, so atomic structure. Well, first and foremost, we have got our periodic table like so, which is a bit rubbish. It's a bit thin at the bottom there, isn't it? Okay, so we got our 3 major blocks. What are our 3 major blocks, ladies and gentlemen? Very, very quickly. Give me 3 letters. Throw 3 letters at me. All right, what are our 3 blocks? Okay, S, D, and P. We got F as well. Okay, so those like our lanthanides and stuff like that. But essentially, we got S, P, and D. Okay, now they represent different orbitals. Now, in GCSE, of course, you were accustomed to this type of structure, weren't you? When you're doing shells of electrons and so on and so forth. So 2, 8, 8, 8, 8, 8. You know, so that's kind of out of the window now. What we're looking at is breaking these down. So these shells, okay, are periods still. Okay, so we've got period 1 with hydrogen and helium, period 2, period 3, so on and so forth. Like I said, my periodic table is a little rubbish. There we go. That's a bit better. So each energy level now represents a shell, or each shell is an energy level. Okay, so what we've got is energy level 1. So that's our first shell here. Now that contains 2 electrons. But where are those 2 electrons? They are in an s orbital. Now, these different orbitals are different shapes. That is an s orbital, spherical in shape. So those 2 electrons, if you like, if you imagine that kind of 3-dimensional, like a ball, and electrons are moving around it, those 2 electrons. So they're not on a ring, they're in a sphere, 3-dimensional. So it's a place where you're most likely to find an electron. It can hold 2 electrons. Any single orbital can only hold 2 electrons. So we've got our first energy level. It's an s orbital, and it contains 2 electrons. Okay, so that would be the electron configuration for what element? That whole electron configuration is for which element there? Tick tock. Yeah, good. Thanks, Ken. Helium, absolutely. Okay, because helium has got 2 electrons. And essentially, they both exist in the lowest energy level. Okay, so the lowest amount of energy. Of course, that first energy level can only hold 2 electrons. So that's it for the first energy level. Our second energy level, however, can hold 8 electrons. So that part from GCSE was true. All right, so the second energy level, second shell, can hold 8 electrons. Now, first one is an s orbital, and it can hold 2 electrons, just like our 1s2. Okay, so we've got 1s2. This is 2s2, holding 2 electrons. Now, what other orbital now gets involved? Because we've got a different type of orbital as well now in our energy level 2. P orbitals, absolutely. Now, our p orbitals are figure of 8 shaped. Okay, now there are 3 of them well, basically they come in groups of 3. So you have one on the x-axis, you have one on the y-axis going from left to right, and then you got one going front to back as well. So imagine them like 8 balloons all tied together, but it's, 6 balloons all tied together at the knot. But they're, like I said, 3-dimensional, and they're 3 figure-of-8 shaped orbitals. Just that single orbital is like putting 2 balloons together end to end, okay, where you tie them just like that. So because there's 3 of them, and each orbital can hold 2 electrons, that's 6 in total. So you end up with 2p6, okay? So we've got 1, 2, 3, okay? So they're holding 2, 2, and 2. So this is the 2p orbitals in the second energy level. And that then continues. You end up with, so 1s2, 2s2, 2p6, that's energy level 1. Energy level 2, what do you think the next one is? Well, that's 3s. Notice how they always start with an s orbital. Then we've got our 3p orbital, which it holds 6 electrons again. And then, because we're into the third energy level, we have got a 3d. Now that can hold 10 electrons, okay? 10 electrons. Now the reason, okay, it can hold 10 electrons is because there's 5 orbitals that are known as d orbitals. And they're all different shapes. Some are like donut shaped. Some are a little bit like p orbitals. We don't need to know. Bottom line, we do not need to know them, okay? So that's where, our knowledge of the shapes of orbitals comes to a stop. So when we're writing these electronic structures, we build it up like this, okay? So if we had lithium, for example, which is atomic number 3, okay, mass number 7, our electronic structure would be 1s2, the first 2 electrons go in there, 2p, no, go on, Rich, 2s2, 2s1, okay? So 1s2, 2s1, thank you, Rasa. So that would be our electronic configuration for lithium, okay? Now for neon, that would be 1s2, 2s2, 2p6. Why? Because neon has got that many electrons. It's got 10 electrons. You find it at the end of the row in group 8. So that's why it's over in group 8, because it's in the p block. Okay, and I just want to point something out to you guys now, and that is that lithium exists here, okay, in the S block. Why does it exist in the S block? Another question. Neon exists over here. Why is that in the P block? So same answer really to both of those questions. Why are they designated in those different areas of the periodic table? No takers? Bennion, the outermost subshell is an s orbital, outer electrons S and P block. Yeah, absolutely. Okay. So the outer orbital. So for lithium, the electron, the highest energy electron, the one that's furthest away from the nucleus. And we can say that the highest energy electron exists in an s orbital. So basically, if your electronic structure ends in s something, you're going to find it in that block there. So literally every element in that block, whatever its electronic structure is and however long and complicated it is, guaranteed it's going to end in either S1 or S2. Okay, so if it ends in S2, it's going to be in group 2. Okay, if it ends in S1, it's going to be in group 1. So for lithium, because it ends in a P, so the last highest energy electron is in a P orbital, then it exists in the P block. So of course, if your electronic configuration ends in P1, P2, P3, P4, P5, and P6, then you know what group it's in. Okay, so it's a nice double check to figure out, it's like, write the electronic configuration of this element. And it's a good double check to make sure that you have written that electronic configuration correctly. Okay, so it's all about the highest energy electron. Where is the highest energy electron or outermost electron? If it's in an s orbital, you'll find it in the s block, that element. If it's in a p orbital, you'll find it in the p block. if the highest energy electron is in a d orbital, so let's say any of these transition metals, okay, here, then it's going to end in d something, okay? Now, yes, Jury, or Yuri, is it, Jury? I was just going to come on to that. So let's say we have got copper, okay? So copper, damn it, I haven't got a periodic table in front of me. What's the atomic number of copper? Anybody got a periodic table handy? I should really know that off the top of my head, shouldn't I? But I don't. Come on, copper, where are you? Everybody, 29. Thank you very much. Dex, come here. Dog's wandering around. Okay, so it's 29. So let's start with the very beginning. 1s2, 2s2, 2p6. So that takes us right across period 2 to the end. Okay, so for me, that's 10 electrons so far. Then we've got 3s2, 3p6. Now, incidentally, yes, 4s comes next. Okay, so 4s2. So that is another 10. So that's 20. That's 20. 4s2, and then 3d9. Okay, because that can hold 10 electrons there. So that's why that's 3d9. So that you would think is the electronic structure for copper, but it's not. Okay, now explanation time. These two, okay, can be written in any order. Okay, but I always write them with the 4s first because the 4s energy level is just slightly lower in energy than 3d. And they're really, really close together. It's like a hair's breadth. All right. So first things first, 4s gets written first in my book. It doesn't matter which way around you do it. Exam boards accept it either way around. But for me, because the 4s is lower energy and it gets filled first, that's why I put that before the 3d. Okay. Now, why is this not the electron configuration for copper? It's about stability. This is one of our exceptions, ladies and gentlemen. Okay. So what happens is we have got a 4s2 like so. Okay. And then 3d9. So we've got 5 d orbitals. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Yes, it is an exception. So the thing is, stability, electron stability or structural stability comes with full or half full orbitals. Okay. And right now, copper's kind of like, yeah, I'm just so close to getting a full outer orbital, so close to getting a full d orbital. Okay. So what it does is, and because these two energy levels are really, really close together, this electron here actually gets hybridized, actually gets promoted, if you like, to this one over here. So what we actually end up with is 4s1, 3d10. Okay. And that is our exception to the rule. So we end up with 4s1, 3d10, and that is the electronic configuration of copper. Okay, mutual repulsion, that's a word, that's a term I haven't used for a while. It's not one that I've seen in any of the specs, but yeah, you're absolutely right. It is about repulsion as well. So that's it. That's the electronic configuration of copper. What is, yeah, because 4s electrons repel, that is true. Okay, hybridized means electrons moving between orbitals. Okay. So we've got copper as one of our exceptions in there. Yes, Yaz, yeah, absolutely. Chromium is the other exception as well. Okay, so that one is 25, 4s1, 3d5, so it's 26. Chromium 26 is the other exception. You'd think it would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. It's not. It's 4s1, 3d5. Okay, and that's an exception for that one as well. Okay. Chromium and copper, copper and chromium, both of those are our exceptions, okay? Both of those are our exceptions, all right? So I want to talk to you briefly now about electrons in boxes, just for 2 minutes, and then we're going to stop because obviously action hours. We need a break before the next hour. So, electrons in boxes. Whose rule is it that states electrons only pair up once if they have to? Okay. So whose rule is that? Hund's rule. Absolutely. Okay. So when we've got oh, they're a bit rubbish, aren't they? So let's say we have got fluorine, okay? So fluorine is 9. So that is 1s2, 2s2, 2p5. So the 1s2 gets filled up first with our opposite spins in our electrons. Then our 2s2 gets filled up, opposite ones. Benyon, it doesn't harm to know the name of the rule, but you will be familiar with the rule, promise you. So 2p5, we do not fill like this. You get to the same point, but you do not fill like that. See what I did there? I went 1, 2, 3, 4, 5. We can't do that because the rule is that if there is an empty orbital, an electron fills that empty orbital before they start pairing up. So it's the bus seat rule. Yes, Hadia, okay? So 1, 2, 3. It's like when you get on the bus, right? If there's a free seat, it's human nature. If there's a completely free seat, we always make a beeline for that free seat, okay? Never has anybody, and it would be considered very, very weird, okay, if you got on a bus, there's one person on that bus, and then you just go and sit right next to them on the seat next to them. That would be a little creepy, and it's not normal. And it's the same for electrons. They will fill empty seats first before they start pairing up, okay? Megan, chemistry is absolutely relatable. I'm full of them. I'm like Mr. Analogy. Some of them might be absolute dog, but they work. All right. Okay. That's it. It's our human nature. Like gents, ladies, you won't know about this, but gents, it's the same rule when you go into the gents and you see all the urinals up hanging on the wall, stuck to the wall. Okay. You don't go and stand next to the bloke. You go, okay, you leave one space next to it. Okay. So you leave one between you if it's all possible. That's the rule. Okay. Would there be any question, asked, and explanation for exceptions like copper? No, not for an explanation, but you are expected to know that it is an exception, okay? You will not be asked to explain it. It is just the way it is, okay? And it comes down to stability at the end of the day. It is more stable when it has either a full or half full outer orbital, okay? So Hund's rule is this, ladies and gentlemen, last thing. So the 2p5 gets filled one there, one there, one there, and then you go back and pair them up. Okay. Now there are times when, it's massively important. I see it in exam papers all the time. So Hund's rule, you fill those electrons in boxes singly and then pair them up. Okay. They do self-isolate, Raseb. Yes, they do. Okay. So, yeah, most of the time they will just ask for as a question. Okay. And we need to talk about ions as well, but that is going to be tomorrow. All right. So how we form the electron configuration for ions, we're going to do tomorrow as well. And we need to talk about the mass spectrometer. So, so guys, I want you to do me a favor. First of all, well, I'm going to do you a favor. I'm going to check that link, obviously, to make sure that you can all get into the chemistry exambulance. What I want you guys to do is do as a solid, right? We're not here like peddling stuff. All right. If anybody wants to subscribe, that's completely up to them. We're not going to be, this is not a sales kind of pitch over the next few weeks. We're just here to help, okay? And we're opening up the course free for people to go and, make some notes and, finish the AS level course or the year 1 course, okay? That's what that aim is for this next few weeks, and to get you exam ready, do an exam at the end, and get you ready for year 2. So spread the word, please, ladies and gentlemen. Stick it on your Insta, stick it on your Twitter, whatever you use. Just stick a link to the exambulance, and we want to get as many people involved as possible, because you know what, we want to help as many year 1 students as possible, because nobody's in school right now. Like nobody's in school right now. So we're geared up to help students, and that's what we want to do. But we just need your help getting the word out there. Okay, so thank you very, very much for coming along, guys, and please spread the word. And I will see you tomorrow at 2 o'clock, where we're going to finish all the atomic structure stuff in a nutshell. Hopefully, if we've got time, maybe look at a couple of classic questions as well. Okay, but for now, I'm going to go. I'm going to start the year 2 one in about 5 or 6 minutes time. Okay, so thank you very much for coming along, guys. You guys are awesome. And yeah, let the world know we are here to help, and I will see you tomorrow. Take it easy.